So viewers, today our topic is the latitude course and speed error. Viewers, today our discussion topic is latitude course or speed error. You know that we have five errors for the gyro compass. Like number one is settling or damping error. This one already we discussed. Today is this one, latitude course and speed error. And next one will be change of latitude course and speed error. And number four is ballistic deflection. 5 is rolling error. Rolling error has two part, like first rolling and second rolling. Guys, this is your rotor is rotating. Okay, this is your north end, this is your south end, so this is the spin axis. Okay, this is the rotor. So you know that earth is rotating west to easterly direction. This is the earth rotational direction, west to east. So this is the rotor is rotating like this way. So your this north end will be pointing towards the true north, that is 90 degree away from the earth rotation, correct? That is 90 degree away from the earth rotation. So this will be the true north, and this is for the stationary gyro. Okay, so here only have one rotation, that is the earth rotation. But guys, your ship is also moving in different course. Okay, so that effect we will show, guys. This is for the stationary gyro. Okay, when the gyro is not moving, only here has the earth rotation. But you know that your ship is also moving, ship has also a course. So in this figure you can see this is the rotation of the earth. Okay, so as per the rotation of the earth, you are getting your true north, which is away 90 degree away from the rotational of the earth. Okay, now now you consider your vessel's course is this way. So if your vessel's course is this way, so your gyro cannot act on two direction. Okay, so after that it will act with the resultant. So your this earth rotation and your ship's course, so there will be a resultant, correct? So this is the resultant, also called RSM, resultant space motion. So after that your gyro can create a gyro north, which is 90 degree away from the this resultant space motion. So 90 degree away from this. So after that maybe this will be your gyro north. Okay, so your gyro north will act with this, with the resultant space motion. After that 90 degree with this is your gyro north. So now you can see your gyro north is deflected from the true north, is westerly deflection. So here this angle is called the latitude course and speed error. Okay guys, how much angle is deflected from the true north? Means your gyro north is deflected from true north. It can be eastward, it can be westward, as per your ship's course. That angle, that much angle is called the latitude course and speed error, guys. Okay, so guys, you can see in this figure, suppose your before course is this one, so now course is this way in south easterly quadrant. Okay, so this is the rotation of the earth and this is your ship's course. So this is your resultant RSM. Okay, resultant space motion is this one. Your gyro will identify this one, a resultant space motion between this earth rotation and the course. Means your gyro will find this one, this resultant motion. Okay guys, after that with this resultant space motion 90 degree away from the resultant space motion, your gyro will show the gyro north. Okay, this is, so you can see now in this figure, that is easterly deflection, and this angle is called the latitude course and speed error. So guys, latitude course and speed error depends on your ship's heading. In this figure you can understand like this. Okay, this is your earth rotation, this is your course, this is your resultant, and 90 degree away from the resultant is your gyro north. So how much degree this gyro north is deflected from the true north, that much angle is called the latitude course and speed error. So in this figure, this is the easterly error. So in this figure, this gyro north is deflected from true north easterly, so this is easterly error. And in this figure, gyro north is deflected westward westerly from the true north. So this is westerly error. Okay, and when there is no earth rotation here, there is no error, guys, because gyro is stationary. But gyro cannot be stationary because ship is moving, so there will be an error. This is the error, guys. I think you understand this one. Guys, you can see for different course you have the error. Okay, but when your vessel course is lies on east and west heading, that time no error, remember. Okay, that time just no error. Okay, only other heading has the error. Okay, so here I have the notes, you can check, and you can take a screenshot, and you can just for a better understanding you can read this one. This is in simple language I write, and this is the figure, same figure there, so you can check this one, guys. Okay, and after that I will show you how to find the latitude, course and speed error, guys. This one you have to know, guys. You can see for finding the latitude, course and speed error, this is for the stationary gyro. This is the rotation of the earth west to east. This is a north and south end moving towards true north. Okay, so this is north end is 90 degree away from the earth rotation, means true north. Okay, so here you can see, just closely if you can see this one, here is your rotor, this is north end showing the true north. This is the rotation of earth rotation direction is this one. Okay, so you can consider this is your vessel's heading, vessel's course is this one. So this up to this much is the speed vector. Okay, so up to this much is a speed vector. So from center, you can, from center of this means from the from here you can draw a line to the speed vector, up to speed vector. So here you can get the RSM. Okay, RSM means this resultant space motion you can get from here. Okay, and remember this, when you get the RSM you get this angle. Okay, so again 90 degree away from the RSM, 90 degree away from the RSM is your gyro north, correct? So 90 degree away from this earth rotation, this one is 90 degree away, so this is your true north, correct? So now from RSM more 90 degree away, from RSM more 90 degree away is gyro north. Okay, so this much angle you need to find. So this much angle is ultimately this angle. Okay, this angle. So if you can find this angle, you can find this angle also. Okay, so our intention is to find this angle. This angle is the same. Okay, I think guys you understand this one. And guys, this I will consider this the A point. So from A point, this is the ship's course, this is the ship's vector, speed vector until this much. You can take it more also, take it less also, this is up to you guys. This after that this angle also will be different, guys. RMS also will be different. Okay, so it depends on the course and the speed vector. Okay, so at A point you draw a line from A to B, means vector up to vector. So this is your RMS, and 90 degree away from the RMS you get your gyro north. So the angle deflect from the true north, means gyro north is deflect from the true north. This much angle is the latitude, course and speed error. Here the latitude, course and speed error is the westerly. Okay, so I need to find this angle. Ultimately this angle is this angle. So here this one you can find. So here I find this one RMS, and this is my base, this is the angle, and this is the height. Okay, from B to C, this is the height. So in this triangle I'll find this angle, guys. This BC is the B cos course, and this much here from your ship, from this point DC is the B sine course. So DC is the B sine course. From A to D, this much is the earth rotation, that is depends on the latitude. So that you know that the formula is 900 into cos lat, or 15 degree into cos lat. So this is this much. So in this figure you can see, if we make like this, tan theta is equal to height by base. This is the angle, so opposite of angle is the height and this is the base. So tan theta is equal to v cos cos by 900 cos lat plus minus v sin cos, because this one can be this side also, so that's why this is plus and minus. Okay, understand guys? And remember guys, this v sin cos, this is for the course and speed. This is very negligible with the, means comparing with the this one earth rotation, this is very negligible, so that's why we will neglect this one. So after that b cos cos by 900 cos lat, so theta angle is equal to tan inverse 1 b cos cos by 900 cos lat. So this is the formula for finding the latitude, course and speed error guys, and this is the way you need to explain like this way. Okay, so this way you can find. And for the compensation method also I write here for you guys. This is the compensation method. Remember there are two methods, one is for Anschutz gyro and other is for Sperry gyro. For latitude, course and speed error, the Anschutz gyro, there is no correction applied on the gyro compass, but they given a delta table. Guys, this delta table is up to 70° latitude and 44 knot speed. So the correction is given in the instrument, there is no correction. So in the instrument there is no correction, but you have to find the correction value for latitude, course and speed, apply this bearing and course. So this delta table is given for the Anschutz gyro compass. Okay, and for the Sperry gyro compass, you know that in the Sperry gyro compass the torque motor is provided. So torque motor is fitted in the Sperry gyro compass. It compensates at the source by introducing torque motor. Just need to input the speed. Guys, in my personal experience I input the latitude and speed. Latitude guys and speed, the latitude and speed it taken automatically in my ship. It was taken automatically from the GPS. So if you take automatically then no problem, but you can input the manually also. So I think you can find also like this, because I found the Sperry gyro compass. Okay, so just need to input the speed because course already have. Okay, because this latitude, course and speed error you have to input the speed only. As for the last video, for the damping or settling error, you need to input the latitude. So for this error you need to input the only the speed. So it will compensate by speed. Input the torque motor and sufficient or equal and opposite torque will produce, okay, to compensate that rate of tilting. Okay, guys, for the Sperry gyro compass torque motor is fitted, so this torque motor produce the sufficient torque as per the ship's speed, and it will compensate the latitude, course and speed error guys. Okay, so this is the compensation method in the Sperry gyro compass. There is a torque motor is there, you just input the speed or manually or automatically, whatever. So it will produce the sufficient opposite and equal torque or rate of precision to cancel out this apparent rate of tilting. So this much error will correct by the torque motor in the Sperry gyro compass. Okay, but for the Anschutz gyro there is no correction, they will provide the delta table. Okay, so I think you understand this finding the latitude, course and speed error, how to find and what is this error. And if you have one question, you can see here, explain with the diagram how the course and speed error is produced and what is the remedial actions manufacturer take to counteract this error. So you have to explain this one guys, like with this figure. You have to explain with this figure the latitude, course and speed error. Okay, and if you can little bit give this one also. This is good if you have time guys, and after that give the compensation method. Okay, so I think you can understand this latitude, course and speed error.